For that, we'll have to break down what does it take to build great analytical Q&A system. And there are three key capabilities. There's natural language understanding of data. The question that you asked, we have to be able to pick the best data entities that you may be referring to. The second part is once you've figured out what are the data entities, you need to wrap them up into analytical clauses such that we can generate the right numbers. And finally, you have to be able to generate syntactically correct SQL so that that SQL can then be executed to get the data.
Today, we're excited to have Utkarsh Ohm on the show. Utkarsh is the Director of AI at Thoughtspot, which provides users with an AI-powered analytics platform. And in this episode, we're going to cover how Thoughtspot built Sage, their AI-powered search engine. We'll also talk about the evolution of AI-enabled products at Thoughtspot over the past 5 years and cover technical challenges, advice on building with LLMs, security, and also, frankly, the exciting outcomes that are eventually delivered to users. So welcome to the show, Utkarsh.
Thank you, Shamik. Thank you so much for having me here. Excited to share what we've been building over the last year or so.
Yeah, thank you. Well, I just want to start off with your background because I think it's very interesting. You've had you've worked with startups before. You've started companies. So, how'd you end up being the director of AI at Thoughtspot?
I studied computer science, and right out of college, I was keen to understand the world of business. So, my first stint was at McKinsey, where I was working with companies to solve business problems. For a year of that, and I realized that I really wanted to build, and that's where I wanted to spend most of my career, and more specifically in startups as much as possible. So I started up on my own. We couldn't get product market fit, so we shut down. But after that, I worked in an early stage startup. But for the last 5 years, I've been working at Thoughtspot. And it's been great because we've been trying to solve problems that are really hard to solve, which are at the cutting edge of the data analytics, the business intelligence industry. And so it's been exhilarating trying to build meaningful products and applying AI in a way that it can not only solve problems, but also bring you some revenue.
That's the best thing that you could hear, and I think a lot of people are especially right now maybe more focused on the exciting parts of AI versus the revenue component. And I think that's something that Thoughtspot's done very well. So we'll get into that in a little bit. But one thing I'm actually curious about is you did not start your career out studying ML and AI. At least from reading your resume, it seems like you learned it on the job. And so how'd you go about doing that? How'd you progress the learning curve at work so that you could end up leading teams in this area?
It's been a few things. Firstly, building systems that are useful from day one has been like a cornerstone of how I've tried to approach whatever problem we've been solving, and then iteratively making them smarter. And when you do that, you often it's not necessary for you to like start off with machine learning. And so what we would see is that in order to solve these real world problems, often you could make something useful for the user by simple statistical heuristics or with feature engineering. And once they start using the product, once you start getting more data, once you can get on conversations with a customer every week, you can start applying more and more machine learning. And as machine learning has evolved, apply more of deep learning and start to break apart the problem into smaller pieces where for most of the problems, you may actually just use distributed systems and data structures and use machine learning for the ones that you can get enough data for, or where science and technology has advanced enough that you can ship something in production and get usage consistently.
When I remember when deep learning was the topic of discussion, I think it was in 2016 or something like that, and then now LLMs are all the rage. And it's funny because LLMs are a neural network, right? At the same time, it's everybody's excited about them now when there were still neural networks that people were experimenting before. And I remember everyone was like, one, they're hard to use. Two, they're a complete black box. We don't know what's going on inside of them. But then now all of a sudden, everyone seems to be completely okay with using the black box as an LLM. Like, what? I don't know if you have an answer to that or not, but why do you think that all of a sudden people are seemingly okay with just throwing everything into this?
I think it's because of just the emergent capabilities. Um, we question why or how we got to the answer lot more when we don't have the right answer. And the pattern matching capabilities or reasoning capabilities of LLMs have just changed things fundamentally. And it's okay. I think, like, if you look at the percentage of startups in this area, there's a small number of startups that are actually looking at how are these models doing what they're doing. And but it's like an order of magnitude more than a year ago. So I'm sure we'll make more progress on that account. But it's just earlier. So ThoughtSpot, when it started out for 11 years ago, it wanted to solve this problem. And every couple of years, when we try to solve this problem by trying the latest and greatest at that time, we would find that the customers had to put in just too much work. But now they don't have to put in as much work, and they are okay with a lot more ambiguity just because we're getting good results.
Yeah, well, I want to actually ask you about that because you joined ThoughtSpot, 6 years ago, and I'm sure that there was already a decent amount of ML and AI that was going on. But of course, you were diving into that and starting to explore that data that you got from users. So, what was the kind of state of AI internally in 2018, and how was it used in products at that point in time?
The state of AI was more word-to-vec embeddings, LSTMs, later on BERT, just POS tagging, like the kind of things that state-of-the-art NLP was using, or state-of-the-art machine translation was using. And the when you try to apply those technologies to um, data analytics or just any B2B app, the challenge is that each business has its own unique circumstances, its own unique problems that it wants to solve. It's the data that they have. That data has its own unique shapes across businesses. So the really hard problem is to get enough data for every business such that you can train models that will work best for that data. And we don't appreciate that as much in our day to day because we use consumer apps that have billions of data points every single day. So all these techniques just wouldn't work as well because of just the volume of data that you could generate for each business. So we would try to learn across general domains, like, okay, can we build a model that's great for financial terminology? Can we build a model for metrics that are most important for healthcare? But more often than not, there would be no generalization. So what's changed fundamentally now, or in the last couple of years, is just the ability to have general purpose reasoning, or have to have general purpose semantic layer, or general purpose machine translation.
But I want to talk a little bit more about that. So, is it that, uh, I mean, I guess why is general purpose so much better than something that was more specific, right? One could argue that maybe it being very specific is actually great because then, like you said, you could help the financial services company, or you could help the healthcare company a little bit better or something. So, why is now, hey, general purpose is so cool, right? In some cases, maybe you do want that specific, right? So, how do you kind of think about that?
You definitely want the more specific, but it helps when you have a great foundation. And that great foundation comes from, in our case, for example, natural language understanding. What can you understand about the question, about the analytical intent from the user's question, that then you can build upon, okay, what does this actually mean? Once you know that they're asking for a number related to sales, you'll try to apply, what does it mean for retail? What does it mean for finance? What does it mean for marketing? But it's layered, and without the former, you just you cannot do much with the latter. All you'll be able to do is, go after one, um, build a business that's focused on one vertical, struggle to get to 10 million ARR, and so on. But if you have to build a general purpose platform, the foundational capability is really the cornerstone.
So what was that chat GPT moment like? I'm just curious. Was the team finally saying, hey, we got to the solution that we've been looking for since the beginning? Or was it still like, hey, let's go and explore a bunch of different things to see what the potential use cases are?
I remember about last October or September when Text DaVinci 2 was the latest and greatest. We were trying it, and this was just like a couple of months before ChatGPT, and it was out for a few months. Now I'm embarrassed that it was out for a few months, Text DaVinci 2, and we haven't tried it. But when we did, we saw that it was out of the box. It was able to do better than some of the systems that POCs that we'd created with some customers with BERT. And that really blew our mind away. And we instantly knew that this is going to disrupt everything. And then when ChatGPT came out, XDaVinci 3 came out, by that time, actually, how that helped us was just drive organizational alignment, at a pace that had never happened before. Because thanks to ChatGPT, now we had, like, all our customers knew that natural language interface was, they had to have it. Like, it had made things so simple that they were like, we need to have this. So it created a lot of demand, and within the company, even people, like 90% of Thoughtspot is not, like, hands down solving this problem, right? Um, that 90% also instantly recognized that, oh, this is so powerful that we just need to, like, double down, and all the hard work that we've done all of these years, the missing piece of technology is here now.
Well, you end up synthesizing all of that, and the team ships Sage, which is the LLM powered product that ThoughtSpot has. So describe what it does for the audience.
Sage is a natural language analytical question and answer system. You, wherever your data is, in any data warehouse, in any data cloud, you just connect ThoughtSpot to it, and your data experts, analysts will do some basic setups of the data model, after which you can come to Sage and ask a question in natural language, and you'll get back a number or a chart that best suits whatever question you've asked. And you can keep doing this over and over. And over time, your answers will get better because we learn from your usage. And over time, you will be able to ask more and more complex questions, and even build upon whatever questions you've asked in the past. Because just in a few weeks, we'll also be launching a conversational experience on top.
But I think ThoughtSpot's product has always had this natural language component to it, right? It's always been this thing where you can just, in the search bar, you type it and then boom, you get answers. So is Sage delivering like an even richer version of that, or a faster version or something? Or maybe it's all of the above. I'm just curious, like what's the key difference between what ThoughtSpot search was doing before and now what is happening with Sage?
Yeah, that's a great question. For that, we'll have to break down what does it take to build great analytical Q&A system. And there are three key capabilities. There's natural language understanding of data. The question that you asked, we have to be able to pick the best data entities that you may be referring to. The second part is, once you've figured out what are the data entities, you need to wrap them up into analytical clauses such that we can generate the right numbers. And finally, you have to be able to generate syntactically correct SQL, so that SQL can then be executed to get the data. Now, the first and the second were, without the capability to understand intent from natural language. The first two were really hard. What's happened is, what we did over the last 10 years was build an experience where we would help you identify the right data entities, help you select the right analytical intent by giving you a domain specific, like a token based search experience, where you had tokens for each of the data entities and analytical intents like growth or versus and so on. And all the usage that you would have would help us suggest you better or help you autocomplete as you were asking the question. But it was still a constrained experience. Now, what's possible is you can completely write a question in natural language, and you don't need to pause. The system doesn't need to wait to give you suggestions. You can just go in there, type whatever, and keep doing it again and again and keep getting answers back.
So what exactly is happening? You write that question. I asked something like, how much revenue am I making on my backpack product or something like that, right? And I'm an e-commerce retailer. What exactly is it? Just one large LLM that is now taking that and starting to do all the reasoning and check everything and work through it, or is there multiple models? Like what is kind of happening under the hood to arrive at the answers that you want to deliver?
You can break it down into these three parts. So natural language understanding of data, the best way to understand how we solve that problem is RAG, retrieval augmented generation. The first thing we do is, based on everything that we know about you, based on everything that we know about the data model, we'll generate hypotheses and retrieve those data entities that you're most likely referring to. And that's what we use the language model most for. Language models are still not great at analytics. They still struggle to understand, even if you say month on month, they struggle to write the right SQL for it without resorting to, like the exact date literals. And we know that models generally don't have a good sense of time. And similarly, like to your question, revenue, what was the revenue for backpacks? You need to tell the model that what could backpack mean. Like you will need to tell the model that here are all the columns. There's a column called product type, and it has these. You'll have to give it some information about the sample values. That there's shirts, there's accessories, there's bags. So it's a two-step process where you tell the model these are the data entities and give it as much context as possible that's relevant, but not too much, because if you give too much, the model starts to get confused. If you tell it that there's product and there's category and both of them have backpack, then the model will just fail to make the right decision. So there's a lot of pre-processing to ensure that we are sending just the right amount of context for the model to pick from. And then the second part of the this process is generating analytical clauses, again using our token based system. We don't force the model to generate it. We ask the model to uh, instead of generating SQL, which is what rest of the world is doing, everybody's doing, we force the model to pick from one of the analytical clauses tokens that we have, and then post process it into the right SQL. So in fact, we're not even getting the model to generate joins. So we depend heavily on the model to do natural language understanding of data, but almost all of natural language understanding of analytics happens using the semantic layer that we've built over all these years, as well as the token-based query language that users are already used to using. The benefit of doing all of this is that ultimately, when we're generating this token-based output, it's also a great way for the users to easily verify the interpretation that the system made. So eventually, when you in the third step, when you show them, instead of showing them SQL, if you show them these tokens that we've generated, they can actually process it and say, oh, maybe this is where the system may have made a mistake, and go in and edit the answer also sometimes, because some of our data experts do that. So it's these multiple systems that are working together 2/3 of which is not even language models.
On that, so I want to, there's multiple questions I want to ask off of that because it's very interesting. Let's start actually, because post processing is just most in my mind right now. But for somebody else, for a startup that's listening to this right now, um, yeah, I guess the question they would ask is, okay, well, why is ThoughtSpot not relying on the SQL that's generated? And is that because of hallucinations? Is that because like you said, you spent so much time building the semantic layer already, so you already have that data, and so then it's just naturally easier to use that? Like what is that the reason, or is it because, hey, it's not good enough at generating SQL?
I think the one line answer is, for real world schemas, for real world messiness of data, models aren't good enough right now. Um, and hallucination is not even the bigger problem, because hallucination can lead, like, you can still anchor the model to pick the right data entities and force it to not hallucinate. If it hallucinates, try to override. But the real challenge is just analytical understanding, which means that if you give a schema that's got 20 joins, which is like we have, most of our customer schemas is more complex than that. Model will not be able to figure out when to do an inner join, an outer join, and even if it is, and I believe over time it'll get better. Like if you train the model on millions of SQL lines, then perhaps you can get better. But there is something more foundational that's required, which is the ability to reason analytically. And the capabilities of reasoning of the models is improving, but in order to be able to reason analytically, you have to understand things like level of detail. Like your data can be at the most granular level of detail, but your question can be one aggregation higher, or your question could actually be two aggregations higher. And being able to differentiate between the two, or being able to show both in the same table, require the model to be able to reason about level of detail and wrap the data entities into the right functions so that they are all at the same level of detail. So it'll take some time before models can handle all of these real world complexities, but it will only happen if um, companies that have these billions of lines of SQL start to train models on it. And I believe it's already happening. Like almost
I'm
every
sure, yeah.
data company is doing that.
Yeah, I'm sure they are. On the pre-processing side, what's interesting is you mentioned, I think you said like product and category, for example, could be confusing. And so you have to specifically pick what you're going to feed, what you're going to retrieve to then augment the LLM, to use the RAG terminology. And I guess, I mean, how do you know, right? How like, do you have a bunch of systems that are running in the background saying, hey, you know, another model that's running on the prompt or question context to be like, oh, this is what this most likely means, or something? Like, how are you actually picking that data?
It happens through a few systems. So we've built indexing infrastructure that crawls through all of your metadata, samples some of your data to learn as much as it can. Then there's a retrieval infrastructure that, based on the question, is able to retrieve um, metadata and again sample data that's most relevant to the question. There's a knowledge graph that gets created as a result of all of this indexing, but also as a result of all the usage. If you tend to always ask the question that you ask, right, revenue about backpacks, if you always tend to use product type and not category column when you're computing revenue, then we'll know it after a few times that you do it. Or, you know, if your analyst has created a few uh, dashboards already with that decision implicit in their actions, then we know that's the right thing to do. Whereas when you're looking at profit, you want to look at by category. We'll know that as well. So it's a mixture of systems built to track usage, indexing infrastructure, knowledge graph, and retrieval infrastructure, all of which we had to build for the token-based search experience anyways. And that's why we were able to like put all of this together and ship a natural language experience like within 3 months, of ChatGPT being released.
That is so cool. I'm just the infrastructure involved in all of this to deliver a product that customers use and actually get value from is just fascinating because it's. I think the coolest part is all the work that you guys were doing before actually ended up being something you could leverage, and that also is a lot of people are asking like, oh, what's the moat around AI businesses, and frankly, it's that like all this that understanding of sure we can use the LLM, but here's how we actually get to the value, and we've already set up all the infrastructure and the semantic layer and everything. I mean, it's really cool. But one question I just have in terms of just availability, performance, like you're relying on so many different things. You have these the pre-processing models that we were kind of talking about. You have the LLM that you're relying on. You've got the post-processing stuff that's happening, and all these sort of things. So it's a complex architecture that's interacting with each other. Is it just, I mean, do you run a bunch of tests? Like, how do you know that this thing will perform? Is it, I mean, what are kind of the best practices that you have to share there?
Accuracy and latency actually are um, not such big concerns because they're improving over time. All the model and cloud providers are throwing more compute at it. The real challenge is accuracy. How can you consistently improve on how many questions you're able to answer? And there, we do things at all three steps. Before an engineer ships any new functionality or capability, there's a robust benchmark that everything that we've ever learned from every kind of query that we want to be able to answer, we try to add to it. And there's no alternate, like you cannot go and use publicly available benchmarks because again they don't have the real world complexity. So we use that benchmark to qualify every single change, but also importantly, we've built an evaluation framework where we look at what kind of complexity is there in the question, what kind of complexity is there in the data set on which the question is being asked, and what kind of errors are we making, so that we can consistently analyze this matrix and continuously, which brings us to the second step, that once you've shipped, you want to be able to continuously monitor if um, everything is working right. But other than traditional monitoring infrastructure, what's new is that the LLMs underneath could start to change. Like GPT-4 was giving different answers for the last few months because OpenAI and Azure were testing by switching off certain layers so that they could get faster latency, and that was just screwing us quite a bit.
Yeah.
So we had to go in and set up canary testing where we run like some queries every few minutes to ensure that like there's a golden set that we never break. And then finally, after you've shipped and you start to get usage, there's also you leverage the evaluation framework that you've used. We also put like all of us are looking at queries every single week that our customers are asking and trying to learn from it. There is so far systems haven't become good enough, like AI systems haven't become good enough that they can look at the output of some other AI systems and make it better. So the short answer is human eval goes you a long way in just continuously improving the product.
Well, I think that's also what ChatGPT is doing too in OpenAI, so it makes sense. But I want to move into a topic that I think you've actually written a blog post about, and also is something that a lot of enterprises I think are dealing with, and so that's kind of security with LLMs. And I guess one question that I have is, I always think about like multi-tenancy. It's something that as a SaaS investor, I always think about what's going on with the infrastructure behind the scenes. And in this sort of multi-tenancy environment, right? I mean, how, like there's data sets are kind of partitioned between everybody, right? Like, does the model need to be partitioned as well in terms of how it's kind of set up? Like, are there complications that result as because of multi-tenant, or is that not really something that people need to be as worried about?
I think we can answer that question in two parts because the answer is different for both. The first is if you're just building off the shelf model, doing prompt engineering on top of it, and mostly building a RAG system on top, um, then you don't need to worry too much about it as long as you've built a very robust um, security system around whatever entities you're going to retrieve. What that means is that if you have access to uh, rows that contain backpack values, like if you have access to the sales numbers of backpack because you are in charge of that uh, part of the business, then when we're generating an answer for you that's using a filter on the product column with backpack as a value, we will ensure that you have access to it. And if I ask the question, I don't have access to it, then that entity will not be used in generating. Like we'll not even prompt the system to prompt the LLM to use it. And even if it hallucinates, even if it, makes something up, in the post processing, we'll catch it because you don't have access to that entity. So that's the simpler answer. The more complex answer is once you start fine tuning, once you start to take all your data and improve a pre-trained model's capability on, say, text to SQL. And this goes back to our earlier point where businesses, it's hard to train something on just one business's data because it's so small. That's where you have to do a good job of just cleaning up the data that you're giving to the model. You have to ensure that no PII or private or proprietary data gets leaked to the model when you're trying to fine tune it, when you're trying to train it. And the way you do it is, and that's the kind of thing that requires work, right? Like if you could just throw everything and build, you will be able to generate a better model pretty fast. And there have been models that have been open source that are fine tuned for text to SQL. But the challenge is solving these kind of problems. So the latter one requires a lot more work. There's, in fact, like we're doing all of that work because we believe that we have the kind of data that can enable us to do better than just any off-the-shelf model. So it's a combination of both that will they'll generally get you to not compromise on your architecture because the multi-tenant architecture really gives you all the benefits that you would want. At the same time, make every customer comfortable that their metrics or definitions are not getting leaked.
I want to move into now the kind of exciting part, right? You did all this work, the team all did all this work, and now it's in the hands of customers. So, what have some of the customer results been with Sage?
Yeah, it's we've got some great feedback from customers. So typically, what we see is there are two kinds of customers: customers who've tried to build this on their own. And there are a lot of customers who've tried to build this on their own because you have ChatGPT and it's a fairly good abstraction to build on top of a text to SQL system on your own. Their response is always dominantly favorable. They're like, "Oh wow, we tried to build it and we know how painful it is. We know how easy it's to build a demo, but it's really hard to build a reliable, consistent experience." So they gave us a 6 on 10 when they 6 months ago when they used us for the first time. And to take the example of one of the launch partners of GPT-4, I can't name the customer, but they were one of the few companies that got early access to GPT-4. So they tried to build the system, a text to SQL system on their own. 6 months ago, they gave us a 6 on 10, and 3 months ago, when we did the next version in early access of the product, they gave us a 9. And
It's pretty cool.
what really, yeah, I mean, we're lucky to be in a place where we can do all of this. So one of the big things that we've learned in the meantime, which we didn't appreciate 6 months back, but just getting to customers and iterating with such, demanding and mature customers, was that all of this aside, you have to put the human in the loop. Once you generate, the AI can generate an answer most of the times, but there's a last mile, there's one nudge, there's one filter, there's something in the definition of the metric that is so unique and special to that use case or that business that it'll be hard for um, any reasonable human also to know, except for the data analyst or the data expert within that business. So, what we've created is a lot of governance and coaching tools so that the data expert can give feedback and, in some cases, even fix queries that they think the system is not able to either correctly interpret or knowledge that the system didn't have out of the box. So, um, that's the experience of customers who've tried it. Customers who've not tried to build it on their own, they take some time to really evaluate how good this is. And they have a more like cynical approach, which is great because then they ask really hard questions. I remember being on a call a couple of months ago with a customer from Asia Pacific, and they had this list of 25 questions, and we there were some hard questions. So to their credit, they had said easy, medium, hard, very hard, and we were on the call, and like I was sweating because they were going in and typing the questions one after the other. And I remember we got 10 or 11 of them right. And then we looked at everything that happened, like what was the gap to 20 out of 25. And we went back to them within 2 weeks, and we were able to answer 21 of them,
Wow.
which is not as appreciated as a company. If you as a we Thoughtspot stage is like a startup within Thoughtspot. As a startup, if somebody's using you and giving you feedback, that's more valuable than anything that you would have done with any smarts that you can build on top of LLMs. So it's a mix. Like often we have to like do some work and partner with the customer to unlock the specific use case that they're looking for. But more often than not, governance and human in the loop gets us a long way.
It's pretty cool though to just think about it in terms of, you went from whatever 10, 11 questions to 20. I mean, that's 100% improvement in a very short period of time. And so although someone may say, oh, it's only 20 questions or something, it's like, well, no, the magnitude of shift in that time period is pretty cool. But we talked, and I think you actually did say hallucinations weren't exactly the biggest problem, but I am just curious, when hallucinations happen, or if they happen, how have customers reacted to them?
I think there are two things related to hallucinations. One is just when the model hallucinates something that's out of whack, that's not even in the realm of possible or related to the data on which you're asking the question. And the second is when it just hallucinates a little bit, like it'll connect the dots somewhere where you didn't need to. So what will end up happening is that you'll generate the wrong answer in the latter, whereas in the former you'll just fail. So the latter is a lot more dangerous, and the latter is what that's the hard part about building with LLMs in our business compared to for chat support or for creative writing. That the cost of giving the wrong answer is really high. So the former kind, where you just hallucinates out of whack, is more simple to solve. The latter kind is really requires, like, you just can't solve it with tools. You have to solve it with a little bit of design and experience. So what we've done is we first give you the system's interpretation in as simplified a form as possible so that you can quickly look, so not just at the data, because sometimes it's hard to just look at the data and verify that the number is right. We also tell you how we got there a little bit. And then we have given a lot of power to the data experts to be able to just test the system quite thoroughly and coach the system such that wherever there is ambiguity. So, for example, in your definition of sales, if you always exclude emerging areas or geographies of business because they're too small, it doesn't make sense for you to analyze them with the rest of your business. When you ask for revenue from backpacks, you just want it from America because the business in South America is too small. You want that to be implicitly included whenever somebody asks a question, or you want that to be implicitly included when somebody from North America asks that question. Those kind of controls have really got us a lot of customer love, and we invested early in it because from our all our years of experience of building like a token based system, we knew how much this last mile of user control matters. And the good news about our business is you have data experts who want to help you build a better system. As long as they don't feel threatened, they feel like this is a tool that they can use to make their day-to-day life better, so that they can do more meaningful, deeper work. Um, they have actually helped us get higher accuracy or avoid running into these dangerous hallucinatory situations.
Well, I think one of my biggest learnings from this conversation is ThoughtSpot's semantic layer must just be a amazing work of art because I know a lot of startups that have tried to build in this space or have tried to build around it or whatever, and I can tell you some of the problems that you just discussed. You know it obviously having built it, but man, those are hard challenges, and it seems like you guys have truly thoughtfully solved them. So congratulations on that. But I guess to wrap things up, we have a lot of technical teams that listen to this podcast, and they're really looking for tactical advice. And you've talked through a bunch of it, but if you were to say one key thing for teams to take away from all of your experience building this, what would you say to those startups out there that are trying to build with LLMs? What would you tell them?
A couple of things. First, build your own data set, evaluation framework, and benchmark. Define your own metrics. There are no metrics that are good enough for your use case. In a few years, maybe we'll be there where you can just Google it or Perplexity it, and you'll find what's the right metric and a data set to get started. But for now, you'll have to build your own. Second, don't discount feedback, especially structured feedback that can fasten the loop of iteration for you. Because if it's unstructured feedback, you'll have a conversation, you'll go back and include it in the product, but still weeks. Can you make it seconds or minutes? And secondly, all the software engineers out there, we have to build an intuition about data. All this time, all the fun that we've had building distributed systems and algorithms and like cool data structures, now we have to really get into building an intuition for the data that our business generates or the data that our business operates on. And it's a different muscle. It's also a different muscle from knowing machine learning or linear algebra. But building that muscle of being able to reason about data, about the quality of your system is going to serve you well in this world of AI engineering.
Well, Utkarsh, that was phenomenal advice, and I think a lot of teams will really benefit from it. I want to give you the chance to talk about any cool things that are coming up for ThoughtSpot in the future before we end things.
I don't want to steal the thunder of our marketing team. We are going to do some exciting announcements in the new year, but Sage and a conversational experience around Sage is also going to be launched pretty soon. There's some exciting work that we've been doing in training our own fine tuning foundation models for text to SQL. A lot of exciting new announcements will be coming up in the first few months of 2024. So stay tuned.
I like it. You put the teaser out for all of us, so now we got to pay attention to Thoughtspot's blog and website and everything to see what's coming. But very excited to see what you and the team ship. Thank you for spending the time and talking through everything, and really appreciate it. I think it's just really cool to see what is traditionally thought of, BI. Everyone thinks, oh, okay, you just ask questions and you get answers, right? And the amount of work that you guys are doing behind the scenes to deliver the right answer from a natural language prompt is just fascinating. So thank you for going through it in detail.
Of course, it's very little that we can do in order to make the world more fact driven, and we all need to come together to be able to do that in this time of rising misinformation. So it's our 2% contribution.
I love it. All right, we'll talk to you later, and we'll see what comes out in the new year.
Thank you, Shavik. Thanks for having me.